Okay, so did you bring microphones? Don't worry, we've got microphones. Yeah, here we go. And you're just going to share. You probably get on well enough, I assume. Okay, great. Right. So first, award-winning question. This is the question. Okay, so what Go package or feature do you think is vastly underrated and deserves more recognition? Anyone can answer.
I think Julie should probably answer.
Okay, sure. So I don't think this one is underrated, but I will say Static Check is probably one of my favorite packages of all time. If you're not running Static Check every day in your workflow, you should. It's helped me figure out so many errors and just things that I would have never caught by myself. So big shout out to Static Check and Dominic.
What does Static Check do for those that don't know?
It basically analyzes your code for things that look, suspicious using like static analysis. So for example, I'll say like you have this argument in your function and you're not using it, or maybe you're like formatting your error in a way that's strange. But pretty much just everything it prints out is amazing and really, really helpful.
Excellent. Yes, please do put your phones to silent for this.
I'd like to answer that question too.
Sure, Jonathan.
So I interpreted this as being about the standard library. So I did my homework, I looked through the standard library, and I came up with 4 packages that I think might be underused. One is runtime metrics, which is relatively new and was developed by one of our engineers to be a great improvement over runtime.memstats and the other things you get in the runtime package itself. So I recommend you look at that. It's a beautiful extensible API for getting metrics about the Go runtime at great detail. And then 3 other packages are you all know about the testing package, of course, but did you know about testing/FS tests, testing/IO test, and controversially testing/quick? So the first 2, so FS test will test your implementation of an IO.fs file system. An IO test, I believe, tests readers and writers, because all 3 of those things have subtle properties. And plug, slog, which I'll talk about tomorrow, is also going to add a slog test package there for testing slog handlers. So I think all those are worth adding to your testing repertoire. Testing quick is something that, if you read that package, it's marked as nothing new. It doesn't say deprecated, but it says we're not going to accept any changes to this. And but I think it's something that is a little underdone in the Go world, which is testing by creating lots of random instances of things and throwing it at your code and seeing what happens. Now, of course, we have fuzzing, which is great for that if your thing consumes like a byte slice or something, like some sort of parser. It consumes a sequence of text or data, and looking for panics in that. But that technique is more general. Like, why don't we generate all the HTTP requests and throw it at your server, or random HTTP requests, and see what happens there. So I think that philosophy of, I don't know the word for it, but some people, I guess, call it quick testing or something, where you generate random instances and throw them at things, is a really interesting way to test stuff. And there is a package in the standard library that will help you with that.
Great answers, thank you. And a quick follow-up then. So what features or improvements would you love to see in future versions of Go?
Really, me again? Okay. Well, Cameron, can you repeat the tagline? Go is the most productive. Go ahead.
To make the most productive platform for building production systems.
So I think about that a lot, actually. I really do, even though it's sort of a marketing line. I think it's a really important goal to set. So I do think about packages that help Go be better to write servers. Usually servers is what I'm thinking about, but CLI tools too. So I don't have any specific examples, but that's what I think about a lot these days.
I've been thinking about error messages lately, particularly given how people seem to love the ones in Rust, and thinking that maybe that would be an area where we could do better to help people onboard easier, figure out what's going wrong easier, and be more successful with Go.
For me, I think I would just want us to be able to continue to live up to that mission, and in particular to enable the ecosystem. I think that's where the future for us is. We're just not unable to like foresee all of it. We're not able to do all the work. It's really up to enabling the community to do that stuff, to build the libraries that others can then build. I think it creates this virtuous circle of productivity for everybody. So it's a vague answer, but I want that to do better.
My answer is that I really want to see GopherCon become part of the Go command. We've been working on it for about like almost 2 years now, probably. I'm giving it, this is what my talk is about tomorrow, so you guys will learn a little bit more about it if you haven't used GopherCon yet. But on a high level, it just helps you find vulnerabilities in your dependencies, and we want to incorporate into the main Go distribution, maybe as something like Go Audit or things that really just help you find software engineering problems like vulnerabilities in your code. And I'm just really excited to see it be part of the main Go command, because then I think that other people can build integrations around it. They can add it as to part of their main distribution without having to do a lot of work to download another third-party tool. So that's the project I'm most excited about right now.
And just to make clear, this isn't any promises we're making, right? Like this is
right.
Yeah, this is just like wave your magic wand and what would magically appear.
Yeah.
Okay. So a piece of feedback I see a lot is that developers want to see better docs. And so what I want to see is a tool or a feature that allows people to write better docs and have more examples in their docs.
What do you think of that? Yeah. I thought Cameron was the lawyer.
Yeah.
Okay, so we have the Go 1 promise, and this is great because it means my book is still relevant, for example. Code still works in it. I mean it, like a lot of languages that wouldn't be the case. But if you were allowed to make one breaking change, what would be the thing you would change? You just can break it, you're allowed to. Anything you'd break?
Yeah, I'll take this one. So the thing that it's something akin to like interoperability with some existing ecosystem. So it's really hard to start a programming language, get it adopted, make it successful. Everyone's written all their stuff in something else, and it's really amazing that Go has come this far at all. To me, like it's like. How is this possible? How did we even get this far without being interoperable with anything else? Just sort of grew on its own. I can see how interoperability for like a language like Kotlin made it it helps it quite a bit. It's like immediately the whole Java ecosystem is available to you. Now I wouldn't want it to like run in the JVM or anything really like that. I just wish there was something, like some thought, some opportunity to make it interoperable with one of those existing ones to smoothen the path out of those languages into Go. As it is, you gotta really do quite a bit. You either have to wait for some entirely new system that you're gonna be building, and then you're gonna say like, okay, yeah, now we're gonna write in Go, even though we have all these other developers. We're all gonna move over this, or it's gotta be a startup where the founders sort of believe in Go and wanna take it there, or it's something like that. If you're building on an existing system or you have like 100 Java servers, why are you gonna write the 101st in Go? That's going to create some tension for you. Even if it is the better answer, it may not be because of your existing stuff. So, something like that. I don't know if that was really like a breaking change necessarily, but it could be.
Yeah. Nice. Any others? Okay.
Okay, so I think this is another question maybe, but I'll talk about the breaking change we are probably going to make.
What?
Yeah. So if you saw, oh my gosh, I'm blanking on her name, Jennifer in Hebrew's name, her talk, she talked about this loop variable capture thing that bit her. And it bit her company so much that she included in a talk about memory management, even though it's not about memory management. That's how bad that problem is. Among other programmers who have been bitten by this bug are people such as Russ Cox. So we're actually going to, well, I mean, I can't say we're going to. I think this is still technically a proposal, but I think So I can't commit to this, but I think in a recent version of Go, not 121, but maybe something after that, there'll be an opportunity for you to avail yourself of that change, so that loop variables will be different on each iteration. We know we've done a tremendous amount of work by going over like all the open source code we can get our hands on, and I don't think we found any cases where that breaks any working code. It breaks many tests and many other code that were, it causes them to break much sooner than they would have otherwise broken, because they are broken. So I don't think there's any downsides to that change, but technically it's a breaking change in the language.
Well, it is going to spoil all the quizzes.
Yes, that's true. Teachers will have to change their tests.
Yeah, but no, that's interesting. Okay, cool. Well, another question then here. Considering the continuous growth and adoption of the Go programming language, what key initiatives or features do you foresee as crucial for the future of Go? Bear in mind you want to maintain the simplicity and the productivity.
Yes, I'll take this one. So I think two things. One is onboarding. And I mentioned this in my talk earlier. There's a lot of new Go developers. So ensuring that they're able to onboard efficiently, quickly, the right way, all of those things, I think that's going to be really important to ensuring that they're successful and then continue to use Go and tell everyone how great Go is, join the community, all of that. And the important side effect, of course, is that some of those things then help existing users as well. If the docs are better for them, they're better for everybody. So that's one thing. The second thing is this other thing I mentioned, the answer to the other question, is the ecosystem. Ensuring that we are reactive to the needs of package maintainers and all those who create libraries, like generics. That was really important, I think, to enabling a lot of different kinds of library use cases. And I hope we see a lot more of that. We've already seen some, but I think that'll enable the ecosystem to kind of lead that path where the Go team cannot. That said, I think we're in an interesting place with AI, or whatever that is, if it's LLMs or if it's like the machine learning of the past. I feel like this is one of those things, maybe, where there's, I don't know, a shift, an evolving needs of developers, like that question asks. And it's really hard for me to say where it goes. I can see, on the one hand, like, what does AI do for Go? So I can think of code completion and things of that sort. And I think that's mostly language agnostic, but we're on top of it to be sure that it really is and that Go performs well in that kind of a process. And we'll want to see where we can do better to be sure that Go developers are able to avail themselves of any sort of assistive functionality from that. And the other is, well, what could Go do for AI? And I mentioned in my talk that graph I showed about open source use of Go, and that I think that's a leading indicator for industry as well. I think, as I keep saying, it takes a really long time to sort of get a programming language adopted. No one's going to fix what isn't broken. So this might be an opportunity where new code is written. This might be an opportunity where new services are created, new companies come out, incumbents are challenged and are forced to adapt, all of those things. And in that case, Go's emphasis on being the most productive platform for building production systems, the one about security, the other sorts of things we prioritize, I think that will bode well for it, that when these new sorts of products emerge, I mean, assuming it's not just integrations with chatbot, it's actually more than that, then I think that's an important opportunity for Go, and we'll have to be responsive to it, and we'll have to be sure that the ecosystem is able to move forward with it. So we're keeping a very close eye on that as well. That, I think, is very important, making sure that when those moments come up, we're ready for them.
Yeah, very good. Oh, again, and if you asked any of those questions, by the way, you've only won yourself some swag, and we'll call you up after. Thank you very much. That was a great answer. Okay, another question here. How are you handling the supply risk caused by Go modules and transitive dependencies?
I believe I should answer that. So I guess to reframe the question, I don't know if it's necessarily that Go modules are causing a supply risk. It's just that when you have code and you pull in dependencies, this leads to some sort of risk. Like if you really think about it, what you're doing when you download a dependency is you're downloading code from a complete stranger off the internet, running it in your computer, and then just like hoping things will go well. Because realistically, we're usually not reading each other's, all of the code bases for all of our dependencies. So I think that the way that we think about this in the Go security team is really just that it has to be an end-to-end solution. Like when you think about shipping software, you start with your source code and you write some code and you pull in these dependencies and then you build the code and you create this artifact and eventually deliver it to an end user. And so something bad can happen at every single step of that supply chain. And so thinking about how can we make it really, really easy for Go developers to just have those protections at every step of their existing workflows is kind of what we're working on. So this is what I'm talking a little bit about tomorrow in my talk about vulnerability management for Go. But the way that we really think about this is just what tools are developers using today and how can we meet Go developers where they are, because most people don't want to sit and think about their vulnerabilities. They just want things to work and then move on with their lives. And so we've been building vulnerability management into package set, into the IDE, into the command line. Like I said earlier, I'd love to see it as part of the main Go distribution in the next couple years. And so that's kind of how we think about it more holistically. And I'll talk more about this in my talk tomorrow.
Oh, great. Yeah, excited for that. And that's the keynote in the morning, right?
It is. Wake up bright and early.
Get up early, everybody. That means take it easy tonight. Excellent stuff. Okay, by the way, it's really warm up here, isn't it? And I know it can't be this, but that fire is really making me... Can we put an ice skate up on the screen, please? I feel like it would work. This question I thought was really interesting. Who do you consider to be a senior Go software engineer? What kind of traits do they have? What makes a good senior engineer? And how can intermediate or junior people reach that point? Yeah, sorry, you've been cut out. I'm afraid you have to leave. You've been voted off. Can you, yeah, let me just
Julie's going to give a better answer, but I'm just going to say that whatever answer she gives is not going to be specific to Go. I hope that's clear to all of us, that like being a good engineer is not dependent on what language you know. Okay?
Oh, round of applause.
Oh, you have...
Got one thing, couple of Rust people in.
Completely agree with that. One thing that we have heard, and maybe for context, I should say I'm the UX lead for Go, so I listen to a lot of feedback and talk to a lot of people that are using Go at their companies. One thing we have consistently heard is that people who working with other languages would be considered more junior engineers, or they would need to have, say, a senior engineer in Java review their code to make sure it is optimized, to make sure that it is going to be as performant as it needs to be. With Go, that's just not a problem. And so you can get people who are much earlier in their careers writing production-ready code, essentially at a much higher level, very easily because of the simplicity of the language. And so I think it does in some ways kind of look different than the more esoteric knowledge you need in a lot of other ecosystems.
Interesting.
So my answer, I guess, so there's two parts to this question. One is, maybe a couple parts. Who do I consider to be a senior software engineer? What traits do they have? And then how do you get there? So I think the first question is probably the least important. Who I consider a senior engineer doesn't really matter. I think that, and in fact, I would actually argue that the title that you have, whether or not you're a senior engineer in one company versus not, is also not really the most important. I think the most important thing in your career is to think about the skills that you have and how you can leverage them to get things done. And so if you feel like you are doing that at bigger and bigger and higher levels and having more impact, I think that's more important than sort of who is a senior engineer or not. Not to say that I don't think titles are very important, but that's kind of like, I guess, a short answer. But if you want a specific answer, Jonathan Amsterdam, I would consider him a senior developer. I think the second question was about sort of what traits and like what characteristics does a senior developer have. And the way that they kind of frame it, I guess like at Google, which is where a lot of my career has been, is this idea of sort of the level of impact you have. And we talked a little bit about this yesterday. We had a Women Who Go panel, and I think what I said was, I feel like when I joined the Go team 5 years ago, I would consider myself a really good programmer. Like I could come in, you could give me a project, and I could figure it out and build it and then launch it and get all the things done. But the way that I thought about Package Site, which was my first project, was really just that it was a web app. I think that as I got more senior, I think about it as more a bigger part of an ecosystem. And so it really is that part about growing from a programmer to an engineer and thinking about sort of what is the impact of this project beyond me and what's the impact of it on the Go community and like developers worldwide. And I think especially in stepping into this role and working in security and thinking about end-to-end solutions, those are sort of like the kind of things that I think a senior engineer thinks a lot more about. And I think the ironic thing is probably as you get more senior, you actually write less and less code. Jonathan likes to make fun of me for this all the time because I barely write any code anymore as a staff engineer. But I think that sort of just thinking about that impact of your work beyond yourself at bigger and bigger scopes is what I think makes a senior engineer. And I think the last question is how can you do that? And I think actually just coming to conferences like this, talking to people is probably, to me, the best thing that you can do. Like all the hard skills you have at work, you can kind of do that anywhere, but I think the thing that gets you to be more senior is talking to developers, knowing the impact of your work, talking to users, and really just seeing like what is the end result that I'm delivering to the end user and developing that user empathy, I think is probably the most important thing you can do to become senior.
That's amazing when you think about it, because really anybody can start doing that today.
Absolutely.
Yeah, great. Oh, yeah, we're just passing the mics. Okay, another question here. This one's interesting. What's the process like for decision making when it comes to adding new features to Go? What is that like?
So it's very data driven. That is the first thing we're always hungry for. Is there some reason before we actually go and do this? Because we only have so many resources, and so we have to prioritize the right things. And that's it can be incredibly difficult. I'll let Alice or Todd sort of speak to that. Oh, nice. I feel better already.
No, all joking aside, that has worked. That's how suggestible I am.
Yeah, hasn't worked for me. So I'd say data is first. And then there is just this other thing, which is like, where we don't have data and we still know we kind of need to, not everything can be supported by like a full-fledged business case. Some of that is going to be like intuition and discussion and having the right people in the room to sort of, the people you trust, the people who have demonstrated that they can kind of think in certain ways, all of that. We're very fortunate to have some really talented, smart people on the Go team. Like I say this, like people at Google are often very smart, but I think the people on the Go team are a little bit smarter. So I think that.
Yeah. I can see now why you're no longer a lawyer.
I think I'll take an answer to that. I think maybe other people have their own perspectives, but I'll talk specifically, not to sound like a one-note, but about the process I went through to build Slog, this standard logging library that I'll be talking about tomorrow. Tomorrow I'll just briefly mention, because first of all, there was a lot of data collected, and I will be talking about tomorrow, but I'll just briefly mention the process that involved engaging with the community in the talk, but I'll talk a little bit more about that right now. So we had this idea, we got from people like Alice and Todd, that the community was looking forward to some sort of structured logging solution. So the first thing we did, I did some preliminary designs, and then we started a discussion, a GitHub discussion with the community. And that went on for maybe 3 months. And there were, I didn't count the number of comments on it, but there were many comments. I think we gave everyone who was able to find it the opportunity to discuss it. And we had extensive discussions there with the community about what was important to them, down to specific details about the names of functions in the API. Then we took that information, iterated on the design, and then did a proposal with the design we came up with. That proposal has over 800 comments on it, and it also went on for several months. And then even towards the end of it, when we sort of said the main design is locked, people still added, there's an additional 7 or 8 proposals about smaller details that we hadn't gotten to yet. This is all coming, the design came from us, but the feedback came from the community. The feature wasn't just function names, it was several whole new features were added because people convinced us that they were important. And we also didn't just listen to the community, to be fair. We also had internal discussions. So for example, there were a lot of people who wanted only attributes and not key value pairs. You'll understand what that means a little more tomorrow. And we just felt from our own intuition about the way Go should look that was not going to be, we were going to include that, but it wasn't going to be the major part of the API. That was something we decided against at least the more vocal people of the community. So it's not purely bottom driven, but we did take a tremendous amount of input from the community, and that dramatically influenced the end product.
Yeah, thank you.
I just wanted to add that I also think the decision process is really different depending on the nature of the project. So slog is something that's going to be part of the standard library. It's something that's going to be lasting. All the decisions we make, we can't really just delete them later on. Whereas a lot of, I've also, what? Oh, but I think that there's a lot of stuff like that for the standard library, and I'm on the Go proposal review committee, and so what we kind of do is like review those decisions on a weekly basis.
Yeah, really smart people on the Go team.
Brilliant up here. But I think that for some of the more greenfield projects that I've worked on, like the Go package discovery site and Go vuln check, those decisions, we don't have sort of the structure that we have for the Go proposal committee where we meet every Wednesday and go through some number of proposals. That usually a lot of times is just like Jonathan and I in a room with a marker, and then we're like, ship it. So it really depends on the nature of the project too.
Yeah, thank you. Okay, generics question incoming. Generics is only supported in regular functions and not methods. What gives? I've rephrased it.
It's technically very hard to do, and I can't give you the detailed answer. I don't know it, but for those who know what the I tables are, the dispatch tables used in interfaces, those are relatively fast because we know the integer offset at compile time of what function to jump to, and I think generic methods would mess that up, and so nobody knows how to implement them efficiently. That's the problem.
Aren't methods, though, just normal functions with like special, just take the receiver as the first argument?
They are, but when you talk about dispatching through an interface, I think that's where it gets tricky.
Yeah, right.
I just wanted to add on to that. This is something that the team hears a lot. In fact, it is the single most popular piece, or most prevalent feedback we get about generics. So, we can't promise anything, but it is definitely something that I think, if there was a technical way to do this, there would be interest in doing that.
But again, no promises. No.
Not lawyer.
Yeah. Okay, this is an interesting question here. Ryan Dahl somewhat famously apologized for adding the Node modules folder to Node.js. Is there any design decision in Go that you kind of regret or we'd perhaps like to take the opportunity to apologize for?
No need for us to apologize. Russ Cox has already apologized for the loop variable semantics. He has admitted to making that decision and implementing it. So that's our answer.
Fair enough. Okay, another question here then. Shortly after GoMod was introduced, there was a brief mention of the possibility of breaking standard library packages into their own Go modules, allowing for each package to independently evolve. Is that still on the table? Is that something you would consider? What do you think of that? Does that actually solve the backwards compatibility problem?
That is on the table, but also the other thing is on the table, which is there's a lot of packages in the X repos that are de facto, standards, like some things in Xsync and Xtime. And we're actually talking about maybe moving them into the standard library. And we are also talking about V2 packages in the standard library.
Ah, so not Go2, but V2 of those packages.
Right.
Yeah. Okay. Are there any plans to allow manual memory management in Go?
Go already has manual memory management. It's called sync.pool. It works really well when you need it. I'll talk a little about it in my talk tomorrow. There's also something out there that's experimental called arenas. Now, an arena is a chunk of memory that you can allocate from if you have to explicitly do it, and then you can just discard the whole arena. And God help you if you have any pointers to that memory still around. What will happen on some platforms is you'll get a panic, but I don't believe that's easily implementable on all systems. I don't think that'll ever become part of the standard library, but I believe it is available. It's open source. Other than that, I don't see us doing anything with manual memory management.
Okay, thank you. You've mentioned that there'll never be a go-to, but there are proposals with a go-to tag. What will happen to them? Are they just going to, should they just be ignored, or are they going to evolve so that they become backwards compatible?
Everyone's looking at me.
I don't know if we have an answer for that.
They will not be ignored. I would, they are effectively treated as potential changes to the Go language that will be either backwards compatible, or if people really love them, we'll do something like we did with the loop variable semantics.
That's right.
Well, this is a good time to talk about a new thing that's going to be in 121, which is a serious, I believe it's going to be in 121, if not, definitely 122. Which is a much more serious commitment to backwards compatibility. Sometimes we do have to break things for security reasons, for bugs, but sometimes people depend on those things. I believe we would break Kubernetes like once every year. And you know, everyone's cool about it, but we want to do better. So we've always had this thing that was this environment variable that you could kind of use in an ad hoc way to retain behavior called go debug. So now that's becoming, I won't go into the details here, but we're getting much more serious about that. We're committed to using that mechanism to ensure that features that, although they may be technically broken, will still be available. If you set the flags right, in particular, the go line in your go.mod file, when you say go.120, that's going to mean a little bit more than it does now. It's going to lock in the features or misfeatures or bugs of that language. I think security fixes are accepted from that policy. So that does give us, the point of all that is that we do have the opportunity to do maybe small breaking changes. So all those go-to proposals are still on the table, I would say, is the short answer.
Oh, that's good news. Thank you. Another question here then. For the testing package, why not include basic asserts and requires like you get in your, I think it's your favorite package, John, the stretcher testify package? And I regret telling him a minute ago that I wrote that because I think this could have been quite fun.
Yeah, right. Stretcher testify is an amazing and beautiful piece of code. Kudos to its author, whoever he may be.
Me and Tyler Stillwater.
It's a principle, it's a design principle of the Go team that we don't think that, again, all deference to you, Matt, we don't think that assertion libraries are a good idea in general because people have to learn them, and sometimes it's like learning a whole new language because they use a Fluent API that's very beautiful and lets you say cool things, and ultimately people reading your tests, and remember people are reading your code a lot more than you're writing it, will basically have to learn another language to understand it. So that's our philosophy. We actually enforce it inside Google. You're not allowed to use that package unless it was grandfathered in for some reason.
Yes, that's going on the CV.
Banned by Google. So yeah, we frown on those packages, and so I don't think you'll ever see one of them in the standard library. But there was a famous therapist named Dr. Ruth who would say, if it works for you, stick with it. And that's my philosophy about that.
Okay. It's not really my place to... This question is something that comes up a lot. This is the question I get asked the most, and we actually just recently did a Go Time episode on this. What is the best place in the project structure to store common structs that are used by both API and data access layers? Is there a right way to do this and solve this problem?
Me again. No. I don't think we have any great answers about project structure, except by the examples that we set in our own repos. But this idea that Cameron spoke about, Go New, as a way of onboarding new people, will, I think, inevitably suggest project structures. I don't like the idea of standardizing on a project structure. I just think it's too dependent on your particular project. I will mention something that someone mentioned, I think, recently in a talk, I think it was Bjorn, about the internal, use internal all the time to make sure that you're not exposing more of your API than you need to. But other than that, I don't really have any advice about project structure.
I think the only thing I would add to that is just that one of the things that I feel like I used to do before I was on the Go team is like make your common project or your utils package, because you're like, this is all the stuff that like I need, but I don't really know what it's called. And I think we're pretty strict on the Go team about not having packages like that, even if they're internal. And I think that that's something that really helps with like maintainability long term, because even if you just have a package of a couple functions in it and you look at it and you're like, I know what this is doing, because me from a year from now is not the same person as me who wrote the code. I think that that is really useful. And then I think the other part is also, I feel like we've had a lot of situations where we'll write and set up our project one way and then just completely redo it. Like the thing that comes to mind was for the vulnerability management project, we have an xvulndb repo and we have an xvuln repo, and we had a lot of trouble figuring out sort of like what is the relationship between the tool and the database, and like should they be in the same repository, should it be in nested modules? They should never be in nested modules. But I think that even just moving that stuff around a lot really helped us figure out a structure that worked for us. And I think what's really beautiful about Go is how easy it is to do that. So also, rather than sort of figuring out what's the right way to start your project, I would also say don't hesitate about just moving things around, and don't have common packages to make your life easier.
Just more generally, like how you should structure your project is sort of this thing that we hear. People have trouble getting started because they don't know, well, where am I supposed to put this folder, the source for this, my tests or whatever. And the answer is you can do whatever you want. But that's sometimes not a great answer. So no promises or anything, but it's something that we're aware of, and it's something that we'd like to investigate, always providing you the freedom, but at least providing you at least opportunities to get started faster without having to address that question.
John, you don't have to learn a new language to use Testify. It's still Go. That's fine.
I'm sorry, was that a question?
Yeah. Yes, from a Mr. M. Annoyed Ryer. No, it's fine. So this questioner says that people who come from other languages sometimes have a difficulty in understanding interfaces in Go and when you should use them and when you shouldn't. Is there any general advice on when to use interfaces and when not to?
So many of you experienced Go programmers already know this. Unlike other languages, you don't have to say that you're implementing an interface when you write a type. And since you don't have to say it, the general rule is don't say it. So in other words, when you write a type, don't also write an interface that goes with it. I believe that's sort of a Java thing that people, as soon as they write a type, they say, well, I've got to have a test implementation of this type, and therefore I must have an interface that they both implement. That's not the way you should be thinking in Go. Write your types, your concrete types. And because Go has this sort of backwards way of doing things where anyone can then write an interface that matches your type signature, your type's methods, you can always let your users write the interface if they need it. And they might need it because they might want multiple implementations of that. But if you don't provide multiple implementations, then there's not really a strong reason for you to write an interface. Of course, if you do provide multiple implementations, then you should provide an interface. So both so that users can use the implementations interchangeably and also as a design point, a place where you can put documentation to say, here's what all these implementations really should have in common. I think that's all I have to say about that.
Yeah, I love the fact that you can do that, and you do forget that often. Like, you can just write an interface for even things from in the standard library if you want to be able to plug that in and have different versions of it or stub it out or whatever it is. I think that's a great feature of Go. Okay, we maybe have time for just one more question here. How committed is Google to Go? There are a lot of initiatives at Google, and not all of them survive. I will be having to remove all my domain names. How committed is Google to Go, and does it matter?
Okay, that's great. I like the second part of that. So we can't speak on behalf of Google. Obviously, we want Go to continue to be at Google. We're employed by Google, and we work on Go, and we love it. And as far as we can tell, very committed. And I think that is correct, with the caveat that sometimes I'm surprised as well. But in general, the Go project is a very valuable asset. Asset's maybe the wrong word. A very valuable sort of ability for Google to demonstrate thought leadership, to build developer trust, to sort of offset those instances where trust is lost. So, the feeling is that it's very committed, with just the caveat that I am not, Sundar, so I can't speak that authoritatively about it. But would it matter? That's a great question, and I've thought about that a lot, and I don't think it would. I think that it would matter, but would it actually derail it, or would it cause it not to succeed? No, I don't think so. I think that it's great that Google invests in it. It provides Google provides a lot of resources to sort of move this along, and that's, I think, great for the community. It's great for the language. It's great for the development and the future of Go. But if it were to stop doing that, I think it has enough momentum now that it can't really be stopped unless, someone like Russ Cox did something to it that I can't even foresee. And even then, I'm not sure. So I think actually it's really great that it has this sort of life of its own.
Yeah, excellent. Well, Cameron, Alice, Julie, Todd, Jonathan, thank you so much. Give it up for the Go team, everybody.